Hello everyone, myself T. Shivapriya, Assistant Professor, Department of Physics from St.Josephs College of Arts and Science for Women, Hosur. In this video, we are going to discuss about the Kepler's law of planetary motion. In astronomy, Kepler's law of planetary motion describing the motions of the planets in the solar system. They were derived from the German astronomer Johannes Kepler, whose analysis of the observation of the 16th century Danish astronomer Brahe enabled him to announce his first two laws in the year of 1609 and a third law nearly a decade later in 1618. Kepler himself never numbered these laws or specially distinguished them from the other discoveries. Motion is always relative based on the energy of the particle under motion. Motions are classified into two types, bounded motion and unbounded motion. In bounded motion, the particle has negative total energy and has two or more extreme points where the total energy is always equal to the potential energy of the particle and the kinetic energy of the particle becomes zero. In unbounded motion, the particle has positive total energy and has a single extreme point where the total energy is always equal to the potential energy of the particle. There are three Kepler's law. Kepler's first law, the law of orbit. According to Kepler's first law, all the planets revolve around the Sun as elliptical orbits having the Sun at one of the foci. The point at which the planet is close to the Sun is known as perihelion, and the point at which the planet is farther from the Sun is known as aphelion. It is characteristic of an ellipse that the sum of the distance of any planet from the two foci is constant. A planet moves rapidly when it is nearest to Sun. It is called perihelion. Already we see that. And perihelion is the fastest motion. And aphelion is the slow motion where the planet moves most slowly when it is farthest from the Sun, or called aphelion. Kepler's second law states that the radius vector drawn from the Sun to the planet sweeps out equal areas in equal intervals of time. As the orbit is not circular, the planet's kinetic energy is not constant in its path. It has more kinetic energy near the perihelion and less kinetic energy near the aphelion. Implies more speed at the perihelion and less speed at the aphelion. If r is the distance of the planet from the Sun at perihelion or minimum and at aphelion or maximum. Using the law of conservation of angular momentum, the law can be verified at any point of time. Therefore, the angular momentum can be given as L is equal to m r square omega. Kepler's second law can also be stated as the aerial velocity of a planet revolving around the Sun in elliptical orbit remains constant. As the angular momentum is constant, all planetary motions are planar motion, which is direct consequence of a central force. Kepler's third law. According to Kepler's law of period, the square of the time period of a revolution of a planet around the Sun in an elliptical orbit is directly proportional to the cube of its semi-major axis. That is, t square is directly proportional to r cube. It's just little bit modify, we get t square by r cube equal to Kepler's constant. Thank you for watching.